So this diagram just says what we're after for the sensory. We have some sensory input. And think of image, think of a sequence of speech, think of a sequence of text. You're reading a text, whatever it is. You're sensing, you're acquiring the information. You want to classify it. The word process stands for either detected, know you have an A, or don't have an A in the sequence of words, or something. You classify it. You want to say this is this letter or that letter, or this number or that number. You want to regression. If you have basic regression, is a word that's used when you have a continuous approximation of something. So we use the word categorization when I have the number of classes are finite. Let's say I have 2 classes or X number of classes. This is categorization. But then if you want to have an approximation of a whole function over some variable, you're approximating a function, we refer to it as regression, as it is in the general literature of signal processing, what have you. And there's also prediction. Prediction, obviously, if you have a sequence of things, when you see that sequence, you say, 1, 2, 3, 4, then you want to predict what the next thing is. So that's the prediction. You want to have the next value. So that's the prediction thing. So that notion is, I have the sensory, I know exactly those labels, and I'm looking for a system that will transform this, and the neural network is an estimated process that basically estimated. And obviously, depending on the training technique and what have you, you could end up with different approximation of this ideal system, right? So if you look at the humans, for example, when we look at faces, we have a mechanism somehow that we recognize faces. We know we differentiate among people. If you ask me how you do it, I don't know. Okay, we do it, and we do it very well, and we optimized it. So there's a system here that each one of us has developed or acquired or finalized or fine-tuned, okay? We're seeking to mimic that system by an approximator, depending on parameters. So we're not reaching that system. We're going to reach a lot of different models, okay? Each one train it differently and get a different approximation based on what? Based on the finite set of training data that you have. That would limit basically the form. So every person, every one of us will train for their own system, and they have a different model. We have a performance on the existing validation data or the testing data, but if we ever deploy our different systems, we cannot guarantee that all of them have the same performance. They'll have obviously different performance. So that's one. So if you look at the details of how we're going to block or build this approximator system, we do it in stages by initially training. We take this sensory data, we divide it into training data, validation data, testing data. Sometimes on these data sets that we have, that's already been done. It's already been divided for you. Other people have done that. You have this data split into those 3 sets. And then they say, okay, use the training data and the validation data to give us a model. Say, sometimes you need to do a pre-processing on this data. So some of the coding techniques is that take that, you need to reformat the data for whatever application you want to have. So obviously there's pre-processing step to massage the data, make it useful for whatever you want it to use. Then you have the approximator, and you do, whether it's a classification for categories or regression or prediction, you do the training. Often the word fit is used in these codes to represent when you do the training. So you give it the training. Training data have an input and a label, okay? Or desired value. And you use the training and you perform your whatever technique, stochastic gradient descent, and you apply all the data. We call the set of whole data is referred to as an epoch. Epoch is the whole sequence of data available in the training. And you walk through all this data, and then you've this one epoch, and you see, and then you make the changes of the weights, you plug the change of the weights, and you see how it performs. On the training data, you say, okay, here's the performance, which is represented as an accuracy of classification, for example. And also you look at the performance on the validation data. And the minute the performance of the validation data and the training data diverge dramatically, then you say, aha, okay, there's a deviation right now between my training activities and the validation data. So the training data and the validation data beyond this point are not going to be in the same class, and if I overtrain, I'm going to have overfitting, which means the model I end up with is going to be very good at the training data and very lousy at the validation data, which is not acceptable. Okay? And I also tacked here the other way of how we envision this reinforcement learning diagram. So your network, and this is obviously represented by the so-called agent here. These are just terminologies people use in the literature. And you have a value and policy of the agent. And what you see, so this represents your network structure here. You're going to form it whichever way. And the network is have a state of an environment. So your robot is receiving sensory sounds and vision and what have you. We call it a state or sensors or what have you. Takes that information. The additional thing here is that this guy has to act on the environment. So you have a robot, basically. It looks at a crowd. It sees, based on the information, makes a decision about moving that way or doing that particular action. So that niche here is that you are acting on the environment, where in the previous structure, we're just doing sensing, passive decision on the data. Let me see. So this is the stuff we talked about, and we're going to reference, obviously, those two books. And the first book is an easy read. The second one has maybe structure and more math stuff. And I'm collecting here for you resources. Obviously, if you've never had any Python experience before, you need to go to a website. For example, you type in Anaconda, and you're going to get to a website called Continuum. How many people have used Python before? Let's see. Okay. So I'll walk through this one. Hopefully, I have a few minutes. Maybe I'll go to that website. Oops. Sorry about that. So I'll just, where am I? Okay, let's just, whoops. So yeah, so this is just summary. There's also keras.io. This is just the software that we'll begin looking at, primarily the Keras, Theano, and TensorFlow. Google Cloud Platform. Okay? So that's a major problem that we had last time, is that we have these codes, we have these libraries, you look at the examples, you want to run it, and you'll be sitting there for hours, okay, waiting for the results. Because, for example, the basic data set is called MNIST data set, which is handwritten recognition, that's often used as a reference point for how well you're performing. That has 50,000 samples of data, 50,000 for training, has 10,000 for validation, and another 10,000 for testing. And when you run that on your PC or what have you, that takes a lot of time. Typically per epoch, which is one pass of the data, I think that particular set will take, I don't know, my computer sometimes like something 2 to 3 minutes per epoch. And if you want to run 100 epochs, so you multiply that and you get an estimate. This is the least amount of data. The other techniques that have more data takes more time and what have you. So we opted last time, we explored in the middle of the semester, basically with HPC here. And the results, at least the experience, was not very encouraging, very positive. People still spend a lot of time. There are people who automated the whole thing. You can automate it, runs on HPC. and we could explore this again, but sometimes they don't provide support for us. We're on our own. We struggle through things, and people, overcome it, but after some delays and what have you. So that's kind of bad. The third option right now is cloud platforms. There's a T here missing, right? Platform. But this is the in thing nowadays, okay? So primarily Google Cloud Platform, which I think if you create an account, you get automatically get $300, okay, that you could use. And people who've used this thing, they often say $100 will be sufficient for doing many things. It costs a few cents, whatever, for execution. But you have to be extremely careful in how you use it. My suggestion, highly recommended. In fact, I'm going to make it something that we have to go through it. I myself am going to have to go through this myself, is to go through this thing here because it's distributed, you can do it from everywhere, and it's the end thing nowadays, yes.
Is there any flexibility that we could choose like Amazon Web Services by any chance?
Yes, you could do that as well. Yeah, so if you use that, that'd be great. That's another option. Yes.
I just wanted to mention because there's a GitHub student pack and they give you money towards AWS, so
yeah.
you can use that.
So that's another thing. So you could use both. Usually, and you have access to either CPU or GPU. Okay. One thing that when you go through this process, be very careful not to have things running when you don't intend them to. There's something called creating an instance, virtual machine, and when you do that, sometimes you think it's not working, and it's actually taking some of the money. There are people who actually have their money consumed without knowing because they left something on. So, and there are a lot of resources. For example, we'll share with you some resources on the web about walking through this thing here. They have tutorials. Anybody had any experience with any of these cloud computing?
I've used it to run a backend before, but I didn't do the classification.
Okay. For what? What?
That was a research project that has needed a backend.
Well, which language? I mean, what you use?
I had like Java and Python running.
Okay, but
Yeah.
any libraries or something for something else, or
No.
not for deep learning, or is it?
No, it wasn't for deep learning.
Yeah. So I think this is the thing is that you could have a GPU on your PC, but then you end up, if you want the right GPU, then you have a heavy laptop, and that's not, a doable thing. Your PC, if you are willing to do things in the background, you could do it. People have done it. It's not, and you could also explore the HPC. My experience last time with the HPC is that, we get caught, things are not, I don't know if you've experienced it, but if for deep learning, it's not sufficient, what we need, okay? For other things, maybe, for other groups that have maybe things that already support, but we didn't have the right support for it, okay? Yes?
I just wanted to mention for the HPCC at least,
Yeah.
if you're running a big job, you can't immediately run it, you have to get in a queue, so that would probably take time. So this might be a better option if you want data, or you want your results faster.
Yep. Yes, so we can also run it in the queue, and you have to estimate what resources you're going to use and how much time. Otherwise, they could kill your job and what have you. So you have to know ahead of time that your job will take at least no more than this much time. If it exceeds that, they kill it. So, but you could explore that. But I think since you're not buying any books, even if it comes down to paying $100 for something like Google Cloud, that will be well utilized, okay? The reason is they also have sample programs and what have you, and I think seemingly it's a trend right now because of the time these things consume, because of the support that these people are providing, the software and what have you, and resources. Either one of those clouds, whether it's Amazon or Google, or I think also Microsoft has its own cloud. In fact, everybody is having their own cloud right now. With that, I think I'm going to, I have still, I guess, 10 minutes or so. Any questions at this point? So how many people feel that it's okay to go through one of these clouds? One of these computing clouds, Google Cloud or the platform or
Is the training gonna be like a
AWS.
whole
Sorry?
day? Is the training gonna be like a whole day or just a couple hours? Is it
I think it's, yeah, it's very, there's some basically tutorials which is really a couple of hours.
Do you know how many dimensions we're gonna be dealing with? Like, are we doing like 50 layers or like?
Well, I mean, you want to go as deep as you can.
Okay.
How is that? Because I think the winning, for some of the application convolutional neural networks, obviously you have to go deep.
Mhm.
And people have done it in competitions, and some of the winning modules are something exceeds 100. Okay? So, I mean, you have to think large scale. You can't just, you can't just stay in the small things. Right now, if you want to do something, impressive, you have to go. Yes. This is from convolutional neural network. Recurrent neural network is different, obviously, story. But I think I'm going to make it, if you have any problems, let me know. But I'm going to make it required to basically have cloud computing. Okay? So I'm not charging you any. I made sure that I get free books for you. Okay, for that class. So your $100 of the book, just put it on that if you have to, or you get 300 when you first log in to something like Google. If you participate in Kaggle competition, you get another free amount. And I think it's doable. And this way, at least, we don't have the nightmare of saying, "Oh, the system is down, HPCC is not working," or what have you. Okay, you get it. This project, you have a week. You got to get it done. Move on. Okay. Okay. Any questions? Any comments?
Maybe if you make another Gmail account, you get another $300.
I'm sorry.
If you make
Yes.
another Gmail account.
Yeah. So I think you can. There's
That's
a lot of
what I
ways.
figured.
Oops. That's what she says. Yeah. She agrees with you. Yeah. So I think, and also we're going to have on D2L, we're going to have basically, I guess something like where we can communicate. I guess for the whole class. I don't know what they call them nowadays. But some platform, forum of a sort that you can exchange information and make it participatory. So if you hear something about some free money here or there or cloud, share it with others. Okay, I encourage you to do that. Okay, anything else? So we want to have it so it's a dynamic kind of process as opposed to rigid format. Okay, and we have to be connected to the community. Okay. Since I have a few minutes, let me see if I go. So here's the Google Cloud platform. You can go there, cloudgoogle.com. So here's the basically the deep learning book.org. You can look at the latest information. Here's the neural network and deep learning textbook, which is, I think this person's been working on it for 2 years and done a good job in starting from scratch. Okay, and he basically walks through using one data set, which is the MNIST data set, and he explains it in a nice way. And also he provides some Python codes here that he can use and run and ready. Okay, these Python codes are basically complete. They don't need any external library. I think his third model uses the Theano library, which you can import as a library very simply. And this is, I think, the page that I like from this deeplearning.net. It has many things, but obviously what we're interested in is the Theano, which is there initially. I think TensorFlow, there are people who claim actually is built or related to or similar to Theano. And MXNet, which, as I mentioned, is supported. It's open source. It's supported by Amazon. TensorFlow supported by Google. And I think we should see, here is Keras, Theano-based. Actually, Keras is more than Theano-based. So you could either select in the back end either Theano or TensorFlow or CNTK, which is from Microsoft. So each group is having its own favorite things, and it doesn't matter which one you have, I think, yeah. What I hear positive things now about PyTorch. I hear some maybe new features that maybe not present in others are just basically, PyTorch is a new library that's supported heavily by Facebook. And it built on Torch, which, you know, had some issues, but I think PyTorch may not be listed here because more recent, I don't see it here. So it certainly is something that people say have certain things. Now, if you go to any of those, I don't know where we are here. Here's Keras. So here's Keras. So you can, in a few minutes, you can actually run a code at Keras. I challenge you, you could run it in 15 minutes. Okay, you can just have, the reason is, in Keras, which can use, here it is, use Theano, TensorFlow, or CNTK as backend. And your assignment obviously is to go all these through things and read it by the next time, okay? So I'll send you basically, you have to explore, read what you can and bring questions and so here's it gives you 30 seconds introduction to Keras. You walk through it. You obviously, you import from Keras models, import sequential. So these are the basic, tells you examples. Moreover, once you go through the basic things, you can walk through and find the GitHub location, which is somewhere I should see.
Bottom left.
I'm sorry? Do you see it here?
Left.
Bottom left?
Yeah.
Your left or my left?
Your left.
This one here? Oh, this one?
There, yeah.
I hope that's what it is. Let's see what it is. Let's see what's next here. I don't know. I can't click on it, so what's happening? No, I think maybe that's for something. Maybe, I'm not so sure right now, but I think what it is, I'm looking for something that says examples here. If you see it, you see examples, you go to the GitHub. I overlooked it here, but I think it tells you how to install it basically after you install Python. So if you really don't even have Python, you can go to anaconda.com, download, and you just basically, typically the libraries are based on Python 2.7 version. Most of the libraries, I think now they're being basically updated for the Python 3, but Python 2.7 is the one that most of the libraries actually are comfortable with. So depending on what platform you have, you can just download it, whether it's Windows, Mac, or Linux. And you download it, you're going to have a host of programs, including Python, that's available, and you can have an interface and what have you. So you can get started with that. So what I recommend you look at initially, look at Anaconda, walk through the process of accessing Python. Okay, and next, will be basically including Theano or TensorFlow and Keras. Okay, and we'll write something briefly for you and have it on the website. Okay, some of these steps. But initially, try to explore it, see if it's something you could pick up on your own. But I'll be sending maybe some sheet through the steps of installing those in case you do. Okay, we'll stop at this point. We'll continue next time. Thank you. And please let me know if you have any questions. It's important to have the questions early, okay? Thank you.